Earth, the only place in the universe known to be home to life. Despite humans looking to the stars for millennia, no trace of life outside our Earth has ever been found. We look out into an otherwise uninhabited universe, alone but eager to find a companion. It's natural to ask, why Earth? What components of our planet are hospitable to life? And the reciprocal question, what is missing on other planets? One key property of Earth is that it has liquid water. We know that liquid water is necessary for all life, and humans are no exception. No life can thrive in the absence of this essential chemical. The Earth is an oasis in an otherwise deserted universe. Vast oceans dominate the surface of our planet. Huge clouds hang above us. Jungles, rainforests, rock pools, swamps. Water is all around us and within us. In contrast, when we look at our neighbouring planets, we see the sun-blasted Mercury far too close to the sun to have liquid water, or indeed even an atmosphere. Venus, which in many ways is so similar to Earth it is called our twin, is drier than the driest deserts on Earth. Neither have life. Mars, a flock of probes have scoured the surface and dug below on the search for life or clues of past life. Chief among these clues being water. The surface of Mars, barren and dry, reveals hints of an aquatic past, where perhaps vast seas and rivers carved their signatures into the rocks. Mars had oceans of water. Perhaps billions of years ago, Mars had life. But today, only a trace of water is locked up as ice at the poles and the planet is dead. No water, no life. It's tempting to think that liquid water is scarce in our universe, and looking at the inner solar system, barring our home, you'd be justified in that belief. But you'd be wrong. One clue to sway us in the other direction is the rings of Saturn. As mentioned in a previous video, Saturn's enormous and mesmerizing rings are almost entirely water ice. Frozen solid, unhelpful for life, but water nevertheless. It's a clue. Likewise, comets, seen through their elongated tails, are mainly water. We now think that the water that comprises the oceans was brought to Earth through a bombardment of countless comets. But there's more. Here's a fact for you. Earth doesn't have the largest oceans of water in the solar system. In fact, by some estimates, Earth ranks 5th for total volume of water of any body in the solar system. That is to say, Earth's oceans are outranked by 4 others. It's not on planets of our solar system we need to turn our attention to, but among the numerous moons of Jupiter and Saturn, unfathomably deep oceans of water can be found. Liquid water that is trapped under layers of ice or other materials, but oceans all the same. Water on a scale dwarfing the Earth's oceans. And in a not too distant future, we will send probes to swim in them. This is the story of the ocean moons of our solar system. We'll explore, in depth, 3 moons and their gigantic subsurface oceans. Please remember to like, subscribe and leave a comment. It means a lot. Thank you. Europa is one of the innermost moons of Jupiter. Discovered by Galileo roughly 400 years ago, it's very slightly smaller than our moon and the smallest of the 4 so-called Galilean moons. It has the smoothest surface of any object in the solar system. The tallest features stick out a minuscule 15 meters or so, no grander than a 5-story building. Crisscrossing its outer layer, we see linea, lines like scratches disrupting the surface. Like fractures, these lines are areas of stress where the surface material has pushed against itself, caused by currents under the surface, not entirely dissimilar to the geological processes on Earth. Our continents are part of a rocky crust, the cold, exposed surface of the mantle. Mantle, which comprises the majority of the material beneath our feet, is essentially a solid. Yet, when you press fast forward to see millions of years go by in seconds, then does it start to behave like a liquid, with currents and convection carrying the continents upon them. Where the continents collide, volcanoes or mountains form, and where they separate, trenches form, plate tectonics, the explanation for why continents are where they are. On Europa, a similar process happens, not with rock, but water, and on a much quicker timescale. On Earth, the thin crust of rock rides above the mantle. On Europa, the crust is water ice, and below, we believe, is a saltwater ocean. The qualities of the surface imply an inner reality. Indeed, the smoothness of Europa, its absence of hills and craters, show that the surface is quite young. The Earth and the Moon are roughly the same age, and yet the Moon is plainly marked through craters, events that happened billions of years ago. In comparison, the Earth has no such scars. The surface constantly refreshes through plate tectonics. On a long enough timeline, any surface feature will be erased. Europa's crust must be refreshed at an even quicker rate than Earth's. These areas, known as chaoses, have an especially high density of linnea. Volcanoes on Earth expose magma, normally hidden away kilometers beneath our feet, to the light of day. Evidence of the drama going on below us. The Hubble telescope detected traces of cryogeysers, liquid water that has been ejected from below the layer of ice, through the tenuous atmosphere, which is mainly oxygen by the way, out into space. Volcanoes of water on Europa. Europa is extremely cold, owing to its distance from the Sun. It's natural to ask, what is the origin of the heat which allows Europa and these other moons to contain liquid water? In other words, why haven't they frozen through? The answer is due to the tidal effects of the dominant planet. For Europa, this is Jupiter. As the Moon orbits, it will not do so in a perfect circle, rather coming closer for some of the orbit and further away for the rest. This causes a differential of the gravitational force experienced by the Moon. For Europa, Jupiter is close by and very massive, exaggerating the effect. This differential in gravity causes friction, and friction on any large scale causes heat. In a very real sense, Jupiter plays a much more important role for Europa than the Sun. When we think of the search for extraterrestrial life, sometimes the notion of the Goldilocks zone is invoked, where a planet is not too close and not too distant from the Sun, so that liquid water can form on the surface. But perhaps this notion is unhelpful, as there are sources of heat other than those from a star which could plausibly help support life. Below the topmost layer of ice, which is thought to be over 20 kilometers deep in some locations, there is a global ocean much larger than Earth's oceans. The average depth of the ocean on Earth is about 3.5 kilometers. The deepest part is the Mariana Trench, which is nearly 11 kilometers deep, which could easily swallow Mount Everest whole. But this is nothing compared to the oceans of Europa. Europa's oceans reach 150 kilometers down. That's 10% of its diameter. Imagine driving at top speed on an empty highway at night, putting your foot down for over an hour. How many towns, villages, human beings would you pass? You'd just about make that distance. As we descend through the water, pressure increases. The enormous mass of the liquid above, its weight bearing down on us. Water doesn't compress, you can't really squash it, even under extreme pressure. Earth's gravity is 6 times stronger than Europa's, which is even less than the Moon's gravity, and weaker gravity means that the pressure builds much more slowly with depth. Submarines designed for the deepest parts of Earth's oceans would nearly be enough to get all the way down to the sea floor on Europa. In these oceans, what will be found? Europa is a prime destination for scientific exploration. The significant volume of water suggests a habitat for life, perhaps a huge aquatic ecosphere of alien whales and schools of three-eyed fish. It's unlikely. There simply isn't enough energy reaching the oceans to support complex life. But the water is salty and probably contains chemicals and molecules that are favourable for microscopic life. Heat erupting from the ocean floor through geothermal vents may allow life like that found on Earth. These ecosystems are unlike any other on Earth in that they don't depend on sunlight for energy. So it is possible, in theory, for life to thrive without solar power, like deep under the layers of ice and water on Europa. Probes have landed on the surface of the Moon, Mars, Venus, and even asteroids, all nearby. But way out in the distant solar system, a probe landed on Titan, Saturn's largest moon, over 1 billion kilometers away. Titan is unique among moons in that it has an atmosphere. Atmospheres act as a cushion for incoming probes, slowing them down from their tremendous interplanetary speeds for a tolerable touchdown. Like Earth, Titan's atmosphere is primarily comprised of nitrogen, yet Titan's atmosphere is more massive than Earth's, despite the Moon being much smaller overall. On a superficial level, Titan has an uncanny number of similarities to Earth. Both have nitrogen-dense atmospheres. Both have mountain ranges caused by geological activity. Both have clouds, precipitation, and lakes. Titan is the only other place we know of where surface liquid settles. On Earth, we have the hydrological system, the water cycle. Water is constantly recycling through evaporation and precipitation. Crucially, Titan has a hydrocarbonic system with lakes and rain of methane and other hydrocarbons, cow burps. In the warmth of Earth's atmosphere, methane is always a gas, but at this great distance from the sun, the cold chills it to a liquid. Methane and ethane on Titan act like water on Earth, powering the weather and causing erosion as it sloshes across the surface after falling in monsoon-like rains. The largest lake on Titan is known as Kraken Mare, which is roughly the size of the Caspian Sea. To us, it would look like a lake of petrol. Liquids, any liquids, are only possible within a cocoon of a protective atmosphere. Throw a bucket of water out of the International Space Station and watch it immediately evaporate. What doesn't evaporate will freeze. The Earth's oceans are compressed into a liquid through the pressure of the atmosphere bearing down on it. Remove the atmosphere and the energetic atoms of the ocean break free and fly around. Gas. But this liquid is not the one in question. What of the water on Titan? Firstly, let's talk about the surface of Titan. These seas of methane are carved into a ground of ice. Water frozen solid at nearly negative 180 degrees Celsius at the surface. Titan is nearly 10 times away from the sun as Earth, but receives just 1% of the sunlight. This surface layer has been measured to slip and move about 30 kilometers in a year and a half, showing that the crust is not solidly linked to what is below. And below is a global ocean. It is not known quite how deep this ocean is. Estimates of depth vary wildly as the data is limited, but in one likely scenario, it extends so far that the pressure builds so great that the water at this depth is squashed into ice. A different kind of ice to what we know. Ice 6, always written in Roman numerals, so you'd be forgiven for calling it ice Vi, where the atoms are arranged differently to normal ice, packed much tighter together. Ice 6 is simply much denser than normal ice, which is why we would find it at the ocean floor. This is an interesting point. Normal ice is less dense than liquid water, hence it floats. This is counter to almost all other materials, where the solid form of the material is denser than the liquid. But when water is frozen, under normal conditions, the atoms self-organize into ordered geometric forms, crucially with quite a bit of space between them. It's like a busy, dense crowd of people watching a gig, suddenly spacing out when they queue for the loo. These gaps reduce the density of ice, meaning it will float on top of water. In ice 6, the atoms are packed together tighter, so it will sink. This peculiar property of normal ice means that the oceans on moons are possible. Ice forms a protective barrier between the liquid water and the extreme cold of the surface. Life in the water oceans may be possible, but current investigations into life on the moon focus on the lakes of methane on the surface. While generally water is seen as the foundation for life, some hypothesize that there could be life lurking in the lakes of methane and ethane, using these hydrocarbons in place of water. Titan is unique in that it has two independent bodies of liquids. The final moon we will be spending time with is Enceladus, another daughter of Saturn. Enceladus is much smaller than Titan. The entire surface of the moon is about as big as Turkey. The country, not the bird, nearly pure white with blue marbling, wrinkled and scratched. Truly a gorgeous heavenly body. The most prominent and striking feature of Enceladus are these plumes of water vapour erupting from the surface, ejecting material into space. This water vapour bursts through the icy surface of the moon from the oceans below, a neat example of the three phases of water. Over 100 such geysers have been found, ejecting tons of material into space every minute. The Cassini probe flew through one such plume on its survey of the moon, so this is the most distant extraterrestrial water any man-made object has touched. From this, we have been given a huge window into the composition of the salty water ocean, including some of the chemicals mixed in, some of which could help life exist. The ice layer of Enceladus is much thinner at the poles. Water from these cryogeysers forms the wispy outer E-ring of Saturn, a rare case of the material comprising a planet or moon escaping and contributing to another object. The surface gravity is very weak, just 1% that of Earth's, so it's easy for material to escape. A jumbo jet, travelling at top speed, would be able to launch into deep space from the surface, if, of course, there was any atmosphere for it to fly through. What trace of atmosphere the moon has is water vapour, which requires constant replenishing as the weak gravity can't hold on to it. Like Europa, the surface shows evidence of the subsurface currents, with cracks and lineae. While the surface is replenished through the materials from the cryogeyser, this happens at a slower rate than Europa. Hence, we can see these craters marking its surface. The oceans of Enceladus are deeper than those of Earth, between 25 and 40 kilometers to the sea floor, although owing to its tiny size, the total volume of water is still significantly less than Earth's. At the lower boundary of the oceans, where the water meets rock, hydrothermal vents are thought to exist. These erupt superheated water from the rocky but water-dense core. Mixed in are other minerals and chemicals, some of which are useful for life. These hydrothermal vents power currents and pressures within the global ocean, ultimately giving impetus to the water erupting through the surface ice. Life could well exist in Enceladus's ocean, life trapped under kilometers of ice, not knowing of light from the sun or the wider universe, blind. Superficially, it contains all the ingredients needed. Life seems to require water, which is in abundance of course, but heat, which the geothermal vents provide, and other chemicals which bubble up from below. We've only scratched the surface of the water in the solar system. Among the moons of Jupiter, Ganymede, larger than the planet Mercury, has overwhelmingly large subsurface oceans, by some measurements over 5 times the size of Earth's. Callisto, another moon of Jupiter, contains nearly as much as Europa's. The error bars on these estimates are large, meaning they are likely to change somewhat as new data is collected. What won't change is the trend, the pattern. Liquid water is everywhere. Unlike on Earth, which is close enough to the sun for liquid water to form on the surface, this water is trapped beneath, or in some cases sandwiched between, water's solid form, a protective shell. Many other moons are thought to harbour water, from Uranus's Titania to Neptune's Triton. Perhaps, under the dense atmospheres of these so-called ice giant planets, even more liquid water can be found. Who knows over the coming decades what can be found? Is there life in these oceans? We can only wait. Water is one of the most abundant chemicals that the universe can create, H2O. 2 hydrogen atoms, the most basic and common element attached to one oxygen atom. Oxygen, also seen as vital for life, is readily created deep in the cores of stars, which when they explode is released into the universe and is the 3rd most common element in the universe. So it's no real surprise that water would also be so common. Water is a universal solvent, meaning it can dissolve anything that can be dissolved, which is one of the most important features for life. Materials dissolved in water can be mixed and intermingle, powering the chemical reactions necessary for vital processes. The water in our bodies is, in a very real sense, a cosmic thing, created by the universe in huge volumes, enabling life. Who knows where else this cosmic liquid is powering other ecosystems? Thanks so much for watching.